Okay. Come on, just carry him. What are the asymptotes? Well, the top doesn't factor,
No.
but the bottom does. How does the bottom factor?
X minus 5x plus 1.
My x minus 5, x plus 1. Now, there are two kinds of asymptotes we're concerned about, vertical and horizontal. And it says list them all. So, tell me what you know. What are my verticals? There's two of them. The vertical asymptotes come from the denominator. So my vertical asymptotes will be x equals 5 and x equals -1. Those are my verticals. Now where does my horizontal come from? The x's. Look at the original problem, which was 3x over x squared. That's all I care about when I'm doing my horizontal asymptote. And what do you notice about that? There's no x squared on the top to balance out the 1 in the bottom. So I'm going to think of that as no x squareds over 1x squared. What is that? What's 0? That's 0. So your horizontal asymptote is y equals 0. If we had had a 5x squared, then my asymptote would be y equals 5. But I don't have an x squared, so that makes it a 0. Y equals 0. Oh, we did number 2 yesterday. Here we go. On our mini review, what do? So we're going to put a -2 in the box. And once again, there aren't any zeros, but guys, please be on the lookout for missing things up here, right? So here, this looks just like what happened yesterday. Those don't cancel. -8, 16, 25, -50. I got -51. Did I do my arithmetic correctly? Right? You okay?
Yeah.
All right, number 3. Oh my gosh, we did this yesterday too. How do we find the y-intercept? Let x be 0. See, this is what I mean, kids. You have to study enough to know what you need to do for each problem. There's 25 and 9, 34 problems. Okay? You ought to be able to know what to do with most of them. Okay, here we go. What's 0.3 to the zeros?
1.
So that's just 1. So I have 28 over 3 plus 4. So that's 28 over 7. 4. So my y-intercept is 4. Here's a new one, in terms of, it wasn't on mini review. Solve. I think I'll start by factoring that last denominator. Does that make sense to you? And now, what do I need to do if I need to solve this?
Make the 2 times x plus 1 and the x, so it's times x plus 2.
So all the denominators have to be the same. So they all have to look like this. So like he said, this one is going to be times by x plus 2. This one is going to be times by x plus 1. And now do all the denominators match? So why did I do that? What can I do now? I just drop them. So we have x plus 2, plus 2x plus 1 equal to 7. So x squared plus 2x plus 2x plus 2 equals 7. Just distribute them. Then what?
About like
Combine like terms. And let's go ahead and get it set equal to 0. And this one, you might recognize does factor. Remember, yesterday we did one with the quadratic formula. You can always use that, but this one does factor. How does it factor? I feel like I've done this already. X plus 5 minus 1. So what are my answers? X equals negative 5 and negative 1. And here's one of those multiple choice things that can trick you. That's gonna be, that's gonna be in the answer blank, but there's also gonna be ones, never mind, because that is not extraneous. I was thinking that was extraneous, but it's not. What would be the two extraneous roots? Negative 2 and negative 1, but it's not negative 1, it's actually positive 1. So those are both good. All right, find the solution set. In other words, solve. That's just a fancy way for saying solve. We are required to have questions in common across all the levels. So some of the questions on your exam will also be on the academic and honors exams. And so sometimes the vocabulary is a little different. But find the solution set, solve. Solve it. So what do we do? Add the 4, for sure, we're gonna add the 4. Now, this is an absolute value equation. How do we do this?
Would you flip the sign?
Well, be careful. We actually have to separate it into 2 separate equations. And the first one is 3x minus 1 equals 6. And the second one is 3x minus 1 equals negative 6. So if you forgot how to do that, shame on you, first of all, because you did it in first year algebra and second year algebra. But, okay, study it. Because, one more time, what do we know about tests in this class? If it's on the review, it's on the test. So you're gonna have to do this. All right, so 3x equals 7, and one answer is 7/3. And the other answer is negative 5/3. Alrighty, now we have an inequality. So what's your thought on solving this?
The middle of the X.
Well, I would like to get that x all by itself, yeah. I would like to have just x in there.
The same thing.
So maybe I will add 4. So I'm gonna add 4 all the way across. Now, what happens here when I do that? Isn't that gone? So now I have 2 less than 3x less than or equal to 15. Now what? Divide everything by 3. So 3-part problem, so I added in all 3 parts. And guess what that leaves me with? My answer. Now again, it's multiple choice. So the answer might be written like that. It might look just like that. It might also look like this, because isn't that the same thing? So don't get confused. If you solve it, you got this, but this is the way the answer looks. Those are exactly the same. This is just interval notation. Right? Well, 7 looks familiar. What are we gonna do with number 7? It says solve.
Quadratic formula.
Probably use the quadratic formula because I don't think that's gonna factor. Do you? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you are gonna have tons of time on this exam, so if it helps you to actually write a equals 1, b equals -7, c equals 4, and write out the formula, and then just plug and chug, do it that way. Just remember that when you square, because some of you are going to, oh, you're not going to have a calculator, good, because you type it in and it's wrong. You're squaring -7, so what is -7 squared? Positive 49, positive 49. All right, so what have I got in there? 7 plus or minus what?
16.
49 minus 16, 33. Ooh, that's a great number to have because 33 does not break down. Now, some of you might say, wait, it's 3 times 11. Yes, it is. But remember, if we're reducing a radical, we have to have 2 of something. And it's 1 3 and 1 11. That doesn't break down. So, that's it. What is the domain? Domain. What are the 2 concerns you have when you talk about domain? Radicals and denominators. Okay, this problem doesn't have a radical, but it does have a denominator. What's the rule for denominators? They can't be equal to 0, right? So what's that mean? If this can't equal 0, then x can't be -2. Again, I need you to think about this in terms of multiple choice. It might say that. If so, choose that answer and move on. But it might also say this. That is interval notation. We spent a lot of time talking about interval notation. Doesn't that mean the same thing? Think about what this says. Doesn't this say, here's -2, and I want all of that? And that says, there's -2, but I want all of that? So what have I got? Everything except -2. All right, oh, 9 is a repeater. We did one like this yesterday. Who remembers what we did? Plug in what?
X plus 1.
Plug in x plus 1 here and here. So 3x plus 1 squared minus 2x plus 1 plus 1. Then what? Foil it. Foil the top. Or the top. Foil the first one. Foil this guy right here.
Do we distribute first or do we?
Oh, no. PEMDAS. What does PEMDAS tell you to do first? Multiply or exponents? Exponents. No, you don't multiply first. You gotta do this first. Okay, so what's x plus 1 times x plus 1?
X squared plus 2x plus 1.
X squared plus x plus x plus 1, which is x squared plus 2x plus 1. That's exactly right. Once you get it foiled, then you can distribute. So 3x squared plus 6x plus 3. But don't get so excited that you forget you still have the other half of the problem to do. You still have all this. Minus 2x minus 2 plus 1. So what's my final answer? 3x squared
3x squared plus
4x plus 2. And that's it. Don't do anything else. Your job was to figure out what happens when you plug in x plus 1, and that's what happens. Number 10 is actually very much like the same problem, except it's worded differently. It does the composition. It says find f of g of x. So you remember what you're supposed to do with this?
So when you put x plus 2 into the f.
Exactly, so it's exactly the same thing as you just did. G of x is x plus 2. So you're going to take that x plus 2, that g, and you're going to plug it in for all of the x's in f. Remember that? It's a notation that tells you to plug the second function into the first. So we'll have x plus 2 squared minus 3x plus 2 plus 1. So my g function goes into my f. Okay, go ahead and FOIL that out. See if you can simplify it. Anybody come up with anything you're willing to share?
X squared plus x minus 1.
X squared plus x minus 1. Let me see if that's what I got. It is.
Oh, we leave it.
Leave it. Leave it. Your job was to plug G into F, and that's what you did. So that is done. All right, now we are sketching. I want to remind you that you can always, if you are unsure about what something looks like, you can always set up a T-chart, make up a bunch of points and plot them and see if you can figure it out from that. That will always work. I don't think it's necessary in this problem, at least I hope it's not for you. This is a squared equation. What shape is a squared equation? It's not a V, it's a parabola. Yeah, it's a parabola. So the normal BFF parabola that you have memorized looks like this. Now, when you start adding and subtracting, you're moving your parabola around. So what does this do to it? Right 3 and up 1. So this parabola has gone right 3 and up 1. Now, what else has happened to it? It's going to flip and be upside down. So you don't have to plot points if you recognize the general equation that you're starting with, which in this case is quadratic. All quadratics, all x squareds are going to be parabolas. in this case, moved and flipped. All right. We know how to do this, we did it yesterday. How do we find the vertex of the parabola? You're finding a point, the vertex point. What do we do? X equals negative b over 2a. I know I keep saying this, but this is such an easy problem if you remember that, but you gotta remember that. To find the vertex, negative b over 2a. So what do we got in this problem? Negative b would be 12, and 2a would be 6. So it looks like my x coordinate is 2. And then how do I find my y? Plug it in. And when I plug it in, boys and girls, come on, remember PEMDAS. You have 3 times 2 squared. What has to happen first? Square it. So this isn't gonna be 6 squared, that's wrong. It's 3 times 4. So it's 12 minus 24 plus 4. So what is that? Negative 8? It's negative 8. My arithmetic right? Oh. You look beautiful today, that extra beauty sleep. Time to just think you all you want. All right, there's our vertex, done. Number 13, write the equation that would result. Okay, now you're gonna write your own equation. You're gonna start with your parabola, x squared. You're gonna go 2 units to the left. So how do we do that in our equation if we wanna move it 2 to the left?
X plus 2 in parentheses.
There'll be x plus 2 in parentheses, because doesn't adding and subtracting to x move you sideways? And we want to go left, so that's opposite, x plus 2. Vertical stretch by a factor of 3. So we want to make it basically 3 times as skinny. We want to stretch it. How do we do that? Put the 3 out front, very good, that's a multiplier. That's a multiplier, it's called a vertical dilation, it's a multiplier. And a vertical shift up 1 unit, so we want to pick it up 1 unit, plus 1 on the end. And there's your equation. There's your equation. Use interval notation to list the intervals where the function is increasing. Now, we talked about this yesterday. What does increasing mean? When you draw it, your pencil is going up. So, I'm gonna put my pencil right here at the beginning of my picture. And I'm gonna start tracing it. Where do I start going up? Right here? What is that x value? Your intervals are x values. So that x value is -3. So my interval starting at -3. Now, where do I stop going up? When I get up here, right? What x value is that? What? That's 1. So all the way from -3 to 1, my pencil is going up. Make a notation. These are x values. You are labeling x values. All right, where do I start going up again? At +3. And where do I stop going up? 4. That's a short little one. There it is. Those are the intervals where my pencil is going up.
We did 4.
Okay. What's the x value of that top point? 4. The x value is 4. We're labeling the x values. That x value is -3. This x value is 4. Label your x-axis if you can't figure it out. All right. Given this, find the x-intercepts. We talked about this. Oh wait, no, it wasn't this class. Another word for x-intercepts are zeros. I don't remember if we talked about that or not. X-intercepts are zeros. So if we were going to graph this, where would I put dots on my x-axis? Those will be the x-intercepts. Where would they be? Positive 2 and positive 4. So what are the x-intercepts?
2 and 2.
Those guys right there. The x-intercepts are the zeros, the dots you put on your axis. Now, find the y-intercept. Well, we've already talked about this yesterday and today. How do we find a y-intercept? Put 0 in for x. So 0 in for x. 0 minus 2 is -2. And 0 minus 4 is -4, but squared is 16. So it looks like my y-intercept is way down here at -32. Now, question C sounds so hard, but I want you to think about something for a second. Remember when we graphed, what was the difference between having a factor like this and having a factor with a squared on it? What difference did that make in terms of the picture? What? Well, what'd you say? The picture bounces, remember? If it's squared, it bounces off. So if I were gonna graph this thing, it would look like this. Because it's just gonna go through that point, but when it hits here, it has to bounce off because that factor is squared, remember that? Every time a factor's squared, it's gonna bounce off. Sometimes it bounces down, sometimes it bounces up, it just depends, but it always bounces. At what point is the curve tangent to the x-axis? Tangent means it just touches. In geometry class, you learned that is a tangent line because it just touches the circle. Where does this curve just touch the axis? Isn't it right there? You're gonna have a tangent point, it's called a bounce off point, every time you have a factor that is squared. That's what we mean by just touches the x-axis. What does this one do? This one goes right through it. This just touches it, it's tangent at that point. So where do we get that point of tangency from? We get it from a factor that is squared, because that's where it bounces off. Well, here's another one. That mini review was a big help, because here's another one we did yesterday. How do we find the inverse of that?
We switch the signs.
So, stop saying switch the signs. You switch your variables. That's step one. You've got to switch your variables. So, this is y originally. So I'm gonna switch it and make it x equals this. Now, I do whatever I need to do to get y by itself. I need y by itself. So I'm gonna add 5. And divide by -2. So my inverse is x plus 5 over -2. Write ln 8 equals x in exponential form. Alright, so let's remember something here. What's ln stand for? Log AC. And we've been calling it log rolling. If I log roll this, it says e to the x equals 8, right? That is an exponent. Now, that's exponential form. So all we have to do is log roll it. You gotta recognize the base is e, and then you just log roll it. So that's the answer. That's it. We're not solving it, we're not doing anything, we're just rewriting it in its exponent form. We did this yesterday, right, as a single logarithm. In fact, this looks exactly like the one we did yesterday. We gotta write this as a single logarithm. So we need to put everything, the whole thing together in one parentheses. So tell me.
Would be 3x2 squared over y.
All right, what do we think about Kate's thought?
Yeah.
She right?
Yeah.
This is the exponent, remember? So that's how she got x squared. That's a plus, so she times these two. That's a minus, so she divided it. Okay, see what I mean about this exam being really short? I mean, we're just clicking through these problems. If you know what you're doing, it's not bad. All right, number 19, another one we did yesterday. What are you gonna do to solve this? Your job is to figure out what does x equal.
Log over.
So you're gonna start by saying 4 squared equals 3x plus 1. So 16 equals 3x plus 1. 15 equals 3x, and it looks like x equals 5. Another sketch. What do you think we might want to do first if we're going to sketch this? What? Factor it. So we can take out an x. Oh, and what does that leave us with?
Difference is squared.
X plus 3, x minus 3? So now when I go to sketch this, I'm gonna put some dots on the x-axis. And where are those dots gonna go?
-3 and +2.
Watch it. Definitely I'm gonna have one at -3. Definitely I'm gonna have one at +3, but what else? You're gonna have one at 0. This is an x cubed equation. Where do x cubes start? Down. They start down here and they end up here. So I'm gonna start down here, I'm gonna grab that point, turn around, grab that one, turn around, and head off into space. How's come nothing's bouncing in this problem? None of the factors are squared. So you just go right through them, right? Connect your dots. That's it, sketch it. All right, last one we'll do today. Find the possible rational roots. So we did this yesterday. How do we find our PRRs? Factors of 6, so that'll be 6, 3, 2, and 1, over factors of 3. So what's my list? Oh, let's be organized about this. I'm gonna take all these numbers and put it over 1. So 6 over 1, 3 over 1, 2 over 1, 1 over 1. So that's just 6, 3, 2, and 1. Put them all over 1. Now, I'm gonna put them all over 3. But 6 over 3, I already have. 3 over 3, I already have. 2 over 3 has to be added, and 1 over 3 has to be added. So there are all of my PRRs. Now, I have to find the roots. I have to actually solve this thing. So what are my options? Could we, these are our guesses, right? Could we just start guessing and dividing? Absolutely 100%. This one also factors by grouping. Now, you don't have to factor it by grouping, but it does, because I can take out a 3x squared, and I will be left with x minus 2, and then minus 3, x minus 2. So I have 3x squared minus 3 times x minus 2. What about this guy? What can I do with that? 3x squared minus 3. We have 3. Oh my gosh. And what can I do with that? X plus 1, x minus 1. So what are the answers to the problem? Negative 1, positive 1, and positive 2. So remember when we were back here and we said we could start guessing? You would probably start with 1 and it would work, right? Or negative 1 would work, or negative or positive 2 would also work. Quickly, since we have time, let's go ahead and guess and remind ourselves what happens when we do that. So let's say I guessed 1. I would put 1 in my box and divide it. Okay, remember that? That's what happens. Then you take what's left and you factor it. So I can take out a 3. And that would factor as x minus 2, x plus 1. So my answers are 2, negative 1, and the 1 that I guessed to start with. So did I get exactly the same answers? Yep. If it factors by grouping and you want to do that, go ahead. Looks like the next set of problems are the calculator problems. So we'll pick up there tomorrow. Also, tomorrow, have your iPad, because we got that survey, you know, you have to fill out all the time. They sent that out to us.